Hi guys, and welcome to this video on finding an equation of a straight line graph from its graph thing. Again, these titles are so long, how is anyone supposed to remember it? My name's Darren, Maths Guru. Welcome to my video and hopefully my channel. If you're watching us on YouTube, can you do me a favor and click subscribe? I'm never going to be rich, never going to be famous, but at least I know that you're watching, and actually that means the world to me, and that I'm not sitting in a room talking to myself going slowly mad by days. And there's maffsguru.com, as you can see above. That's got all these videos with downloadable notes and so much more. Now, what do I mean by downloadable notes? If you download the notes now, if you pause the video, download the notes, you can write all over them in addition to what I'm about to do. Oof, life couldn't be better. What is my learning objective? Know how to find the equation of a straight line from its graph. So in a previous video, what we've done is we've looked at the idea of if we were given an equation, say y is equal to 3x minus 2, how would I draw that? Well, I could draw a table of results and I could create values and I could plot this thing and draw it together. Or like I did in the last video, we can go, well, hold on a moment. We know that that there is the gradient. We know that there is a coordinate, which is 0, minus 2. And I can actually use that to sketch a graph. So I can draw a point at 0, minus 2. I know that this thing here is 3 on 1, which means 3 up for every 1 across. And I can go 1 across and 3 up and 1 across and 3 up and 1 across and 3 up and draw them together. And lo and behold, I've now sketched my graph. It's like doing the table of values, but not really. And that was certainly one way of doing it. But what happens if they give you the graph and you've got to find the equation of a straight line? Well, hopefully you're not going to find that particularly difficult, because what do we know? We know the equation of a straight line is given by y equals mx plus c. So if I've got a graph and I can find this gradient and I can read off the y-axis intercept, and again, don't get tricked, it's not the x-axis intercept, no, it's the y-axis intercept, I can just put it into the equation and ka-ching, I've got my straight line graph, or I've got my equation of a straight line. All right, let's have a look at an example. We've done so much on the gradient before, all right? So let's have a look. Can we determine the equation of a straight line graph from the graph shown? It says opposite, but it means below. Well, the first things first, let's read off the intercept. That's always the easiest part of the graph, right? So look at the vertical axis and read off the value. What do we notice? Well, it's crossing through at the value 2. I now know that my intercept is equal to 2, yeah? Now, actually, I normally put a plus in front of that just to remind me, or it's going to get confusing. And all of this comes back to my equation, y equals mx plus c. Now, again, if you've printed off the notes, you can write down and annotate and put extra stuff in here. What do we now need to know? So we've got the c, we've got that c value. We need to know my gradient. How do we find the gradient? Well, the good news is you choose 2 points on the line that you can then find the across and up to get between those 2 points. Now again, I think I've shown this before, that I tend to choose points that cross exactly through a known equation or a known point. So actually, funny enough, I tend to always start, if I can, with my intercept. It makes life a lot easier for counting, all right? And I'm going to try and find another one now that where it goes through. Now, believe it or not, I'm actually going to choose this point here. You know why? Because that red line is going through an exact grid point, all right? It's going through the coordinate 5, 9. Now again, you've done this, we know how to do this, yeah? So, but let's just actually see whether we can draw the triangle first. So if you notice, remember, I draw a triangle, a horizontal line between the two. Now you wouldn't draw more than one line, I'm just drawing this to try and make it clear on the video. So what I now say is, well, how many squares is that graph gone across? Well, it starts at 0, it finishes at 5, so it is 5 units across. Ka-ching. How many units up has it gone? Well, it starts at 2, it finishes at 9, and so it must have gone 7 squares up. Now, you're going to turn around and say, oh, it doesn't divide nicely. It doesn't matter. You know, maths is going to try and trick you. So what do I now know? I know my gradient is equal to 7, right? Because it is rise, so 7 divided by run. And all I need to do is make sure that is my graph a positive or a negative gradient. It is positive, congratulations. So I'm not going to put the plus in front of it. I don't need to. So do I know everything I need to know now? Yep. So I now know that y is equal to m, which is 7 on 5, x, what was my intercept, plus 2. And remember, the reason we're using the letters y and x is because my axes are labeled y and x. Cool. All right, let's have a look at another one. Find the equation of the straight line shown. Let's see what we can come up with. So again, remember, it's always easiest to read off the intercept. So here is my intercept. So I now know that c is equal to 1. We'll write the equation over here that we're trying to get to, y equals mx plus c. We now know c, we need to find the value of m. Again, I'm going to use this coordinate point here as one of my points on my line, and I notice that this one here seems to cross through exactly. So let's draw my triangle. Is that going to work? Brilliant. So how many squares across have I gone? Well, I'm starting at 0, I'm finishing at 1, so it is 1 square across. How many squares up have I gone? Well, I'm starting at 1, I'm finishing at 4, so I've got 3 squares. Have I got all I need to do? I should cocoa. So let's just check there. We know now the m is equal to rise, which is 3, divided by 1. And is it a positive gradient or a negative gradient? It's positive, so I'm just going to leave it as positive. And again, we know that 3 divided by 1, any number divided by itself, is in fact 3. So my answer here is y equals m, which we've decided by 3x plus 1. Now, why is it plus 1? Because there is a plus in front of that 1. Ka-ching, ka-ching, happy little dance. All right, so there we go, job done. What about this one? Do you see the trick? Oh, I see the trick. All right, so let's start the same thing. We've got y equals mx plus c. All right, what are we trying to do? So I'm going to start off with my intercept. Yeah, now again, it's not this one here. That's a trick. We're not interested in that. It is this one here. It has to cross the vertical axis. So we know that c is equal to plus 3. What can we do now? I'm going to choose 2 points. Let's choose this one here. And I'm going to choose, let's say, this one here. Why did I choose those? Doesn't actually matter, so long as you've got 2 points that are easy to read off of my graph. Okay, so let's do the horizontal first. How many have we gone? We've gone from 0 to 2. So we've gone from 0 to 2, which is 2 squares. And we've gone from 1 up to 3, which is also 2 squares. So my gradient is equal to rise, which is 2, divided by my run, which is 2. But is it a positive graph or a negative graph? It is negative, so I'm going to put a minus sign in front of there. Can we simplify 2 divided by 2? Well, yes, because any number divided by itself is in fact 1. So that becomes minus 1. And ladies and gentlemen, now in fact, in many cases, the gradient here is the hardest part to do. Why? Well, you've got to make sure you've got the positive and negative in the right way, and other teachers teach it in totally different ways. I'm not saying that I am right or that they are wrong, but we can now say that my equation here is m, which is minus 1, times x plus 3. Now again, I wouldn't write minus 1x because we don't normally write the 1. So that would be the same as minus x plus 3. They are all the same. It's not a huge issue. Worry not. Now you're going to turn around and say, but hold on a moment, why did you use y and x? Your axes aren't labeled. No, they're not. So I'm going to label them now, and ka-ching. Another example, all right, let's see where there's a trick with the intercept here. Oh, do you see what it is? Well, first things first, my intercept is there. So I'm going to write c is equal to 0. So if you've seen the previous video, you'll go, okay, you talked about that in the previous video. I did, absolutely. So where are we going to go here now? Right, we are going to go and do this point up here. Why? Well, again, because it's crossing through a very nice coordinate point for me here. So I'm going to draw my triangle. He says, drawing that really badly. And again, I'm going to look, is it positive? Is it negative? It's positive. So my gradient is equal to the rise. So I've got 4 to 0. From 0 to 4 is 4. And I'm going from 0 to 1, which is 1. So we've got 4 divided by 1. Is it positive or negative? It's positive, and in which case, that's just going to become 4. Again, because any number divided by 1 is always its number. So have we got what we need? Y equals mx plus c. So y is equal to my gradient, which is 4x plus 0. And do we write the plus 0 on? No. Again, that's one of those things that we can, in maths, just leave out. And believe it or not, that's the end of this video. Thank you so much for watching. Hopefully it's useful. Now go away and practice, because practice makes perfect, yeah? We're going to get a little bit later on to things like horizontal lines and vertical lines, and all just bits of tricks. But at this moment in time, if you can do vertical, positive and negative gradients, you're going to smash this. There are 2 more minutes coming for this video. If you can watch it, greatly appreciated. If not, sign up to Maths Guru, totally free by the way. YouTube, subscribe, and hopefully I'll see you in another video. Take care guys, I'll see you again. Thanks very much for watching guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise I feel like I'm sitting here just talking to myself. And then yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos, you can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care guys. See you again. Bye bye. Stay safe.